All right, hello everyone. Yeah, this is a topic which has been on my heart for quite some while now. So what I wanted to figure out is what the range of healthy tissue is. Um, yeah, so I want to use this to then okay, so yeah, I yes, so I wanted to figure out how what like the healthy range looks like, and I want to do this because if you can figure this out, then you can kind of, I guess, constrain the space a little bit of what's possible, and you don't need to, train a model to kind of predict everything, but just within those ranges, and then you can also focus on what happens in a sample. You can do this, of course, without constraining like what healthy looks like. But so first, the idea of this is to have a range of healthy states, and then to predict what happens in a sample, because then one, you can kind of figure out do you have enough data to represent well enough the have enough data that when something new comes in, that this just also falls within this healthy state, and that is kind of hard to figure out, and then yeah, you can just focus on like what happens, because you have the whole range, and then yeah, lastly, you can then understand what happens in a perturbed cell, and a disease state. And what I'm doing is I don't want to predict, like, given like a perturbation, how a transcriptome looks like. I want to know what this tells us, that you can kind of understand the whole the transcriptome as a whole, as compared to how we currently do it, that you kind of just choose specific pathways and look at those. I mean, you don't really have a holistic picture of the cell. Yeah, and of the next. Yeah, and then my hypothesis to kind of make everything more simpler, to make everything simpler, is that the most relevant signals are encoded in the RNA, in the mRNA expression, and you don't really need that much of like different or other information. Yeah, of course, this is like the proteins are also relevant to look at, as well as like non-coding RNA, but this would just explode this project. And yeah, so then you also have like different, to figure out what is healthy, you kind of need to, I guess, look at the distribution of the gene expression for each gene, and there you can kind of find that you have like some unimodal genes which follow like the bell curve, and then also have some genes which have a larger distribution, or like a larger range of values in which they fall in uniformly. Yeah, so and this is relevant because of like you kind of want to, for each gene, define a range which is acceptable, and yeah, of course, this is larger than if you have this like uniform distribution in there, and yeah, you want to like the the best possible range you want to define, and this is kind of, I mean, it breaks down in one, the kind of the quality of your sequencing, like how accurate can you actually predict or like measure, but then also but yeah, then also how but also like what is the general biological variance in there, and then because genes, like, they don't move independently, you kind of want to define some set size, or you want to get some set size for which, like, in which they fall into, yeah, because this then helps us to further constrain the space, because then you can kind of say, okay, so if it's in one sample expressed like with those neighbors, then it also needs to be expressed like that. It also must have those neighbors in another, for another gene, and then you have like a further reduction of the space, and yeah, then we want to tighten those intervals, because the smaller you get, the like more constrained the space, and also tighten or like increase, I guess, the like the gene sets. Yeah, and it doesn't really, like, what I should mention about this, it's not important that you increase the amount of neighbors per cohort, and yeah, because I would assume that there's like a lot of variance between them, like, I mean, just because of the environment is different, or the age is different, so many different things which can be different. Yeah, and for the data, I will just like share the GitHub repo below, and there you can calculate it all by yourself. I mean, to talk about some finding, is this, I think, which is the best which I have gotten it currently, is to have it so that you have like the multiplier at 0.1, and then you have still a large amount of gene sets, some empty buckets, which means there's like no gene which is shown up as a neighbor, and like a decent acceptable size for the gene set,